Section 1.4 Properties of radicals. In this section, we look at the radical notation, simplifying radical expressions, combining radical expressions, and also look at the rational number exponents. For the radical form or the n root of A is called the radicand, n is an index, and the root form is the radical sign. For the n root of A equals B, it's the same as the statement A equals B to the power n. For the index n, if n is an even integer or the even natural number, the A or the radicand must be greater than or equal to 0. In the case that n is an odd natural number, A can be any real number, so no restriction. For example, we look at the fourth root of 81 equals 3, which is equivalent to the statement 81 equals 3 to the power 4, where we look at the fourth root of negative 81, no such real number that would make the statement as negative 81 equals some quantity raised to the fourth power, because the fourth power, that means the quantity multiplies itself 4 times. So either negative or positive sign times itself 4 times, the result gonna come out as positive number. So then the restriction for the radicand is the radicand or the A must be greater than or equal to 0 for n or the index as an even natural number. For n is odd, it can be both negative or positive radicand, like the examples that you see in the table. The cube root of 8 equals 2. That is equivalent to statement 8 equals 2 to the third power, because 2 times itself 3 times equals 8. For the cube root of negative 8 equals negative 2 is equivalent to the statement negative 8 is the quantity negative 2 to the third power. The form the n root of A to the power n is absolute value of the A. If n is an even number, the n root of A to the n equals A, which is exactly the same as the radicand, the base of the radicand, if n is an odd number. The notation form as the n root of the A is equivalent to A raised to the power 1 over n. For example, the square root of the A is the same as A to the power 1/2, or the fourth root of A equals A to the power 1 over 4. Another notation, the n root of A to the power m, which is the same as the n root of A quantity to the power n, is the same as A to the power m divided by n. For example, if we have the third root of A to the fourth, it's the same as the third root of A to the fourth power, which is the same as A to the power 4 over 3. The next one is A to the power negative m over n. When you have the negative power, the expression can be rewritten as the reciprocal of the positive power. For example, we have A to the power negative 1 over 2 is the same as 1 over A to the power 1 over 2. For the properties of radicals, the first one is called the product property. When we have the n root of A times B is equivalent to the n root of A times the n root of B. The second property is called the quotient property. The n root of A over B is the same as the n root of A divided by the n root of the B. The last one is the m root of the n root. So you can write it as the n times m root of the quantity A.